Hello, this is Mr. Stansbury. I'm going to take you through the imaginary unit I. At the end of this, you should be able to say, I know the definition of the complex number I and how to write it in A plus BI form. And I can graph complex numbers on the complex plane. All right, so let's, I think the best way to do this is to show you an example here. So here's what we're going to do. We're going to find square root of -4. And square root of -17, square root of -8. So first things first, we know we can't take the square root of a negative. So we're kind of stuck, right? So someone back in the day decided, hey, I don't want to get stuck when I get the square root of negative numbers. So they created this imaginary unit, okay, called I. An imaginary number is a number written in the form b times I, where b is a real number and I equals the square root of -1. Okay, so wherever you see an I, that's the same thing as the square root of -1. Okay, so that means what we can do with this is we can actually take this square root of -4 and turn it into square root -1 times the square root of 4. And actually, I'm going to write it the other way around. Let's do square root 4 times the square root of -1. Okay, so square root of 4 we know is 2, and then square root of -1 is just I. So this here, square root of -4 would just be 2I. Okay, now this square root of -17, we can rewrite that as root 17 times the square root of -1, and we know that square root of -1 is I. And then we have 17. That doesn't end up being a perfect square, so normally the order that we write this in is going to be I root 17. The order that we write this stuff in is going to be real number. Actually, let's do not even real number. It's going to be a whole number. First thing we're going to have is whole number, and then imaginary number, which is the I, and then the next thing we're going to write is the root. Okay, so if we happen to get a whole number, an imaginary number, and a root, we write them in that order. I'll show you what the heck I'm talking about. Square root of -8, we can turn that into square root 8 times the square root of -1. Okay, we know that square root of -1 is just I, right? And then 8 actually breaks down into 4 times 2, right? And we know square root of 4 is 2. So we have 2, we have root 2, and we have I. The order we want to write that in is whole number first, so the 2, and then the imaginary number, I, and then the root 2. So we write that as 2I root 2. Okay, so that's how we would solve these. That's how we would find these using imaginary numbers. Okay. Now, a complex number is a number in the form A plus BI, where A and B are real numbers, and I is the square root of -1. So for an example, we could now have 7 plus 2I root 3. 7 is our real number, our real part, and then the 2I root 3 is our imaginary part. Okay. Now, with that, we're going to identify the real part and the imaginary part of each complex number. So we'll just call this the real part is going to be R, and imaginary part is going to be I. So 14 is the real part, 2I is the imaginary part. -5 is the real part. I root 3 is the imaginary part. So basically anything with an I in it is the imaginary, and whatever the other term is, right? Because these are separated by, these two terms are separated by the positive, and the positive there. Sometimes negative. The imaginary number always has an I in it, and the real number does not. So this one here is just a real number, and this one here is just one term. That one's just the imaginary part of the complex number. Okay? Okay, we got a couple more things to look at, but first, let's take a little comedy break.
Poor kids. Bedtime is a crisis. That's why I'm here right now. It's too hard. They act like they've never been to sleep before. Bed? What's that? No, I don't want to do that. Then it becomes some hostage negotiation, but in reverse. Look, if you stay in there, I will give you whatever you want. I will meet your demands. What do you want, a helicopter to Cuba? Anything. Just stay in there. There's always one awake. Like they're taking shifts. All right, I'll annoy him from midnight to 2. Who wants 3 to 6? Now let's lie down and practice kicking him in our sleep.
All right. All right, so we can actually graph complex numbers on the what we call complex plane. Complex plane is a 2D plane where the horizontal axis is the real portion. So here's the horizontal part. That's the real axis. That's where the real numbers are going to go. And then of the complex number A, and the vertical axis is the imaginary portion. That's the imaginary part of our complex number. Okay, so with that, let's graph the complex number -2 plus 3i. So really, I just kind of look at this really as like coordinate, right? So this is our coordinate here. -2 is our real axis, so we go -2, and then plus 3i. 1, 2, 3. Right there, that point there is -2 plus 3i is this point. Okay, so really it's just like coordinates. Okay, now with that, let's graph some of these. Okay, we're going to graph each number on the complex plane. H. 5 is the real number, 5. So remember, this is real, and this is imaginary. Okay, so we're going to go 5, and then it's minus I. So there's 5 and then down 1. This is point H. Okay, -7 is to the left 7, and then plus 3i. 1, 2, 3, up. This is point I. And then J is just at 4. Right there is 4. There's no up and down. There's no imaginary piece to that. So it's just going to, if there's no imaginary piece, it's just going to be on this real axis right here. So that was J, and then K is -8i. So that's just down right here. So this is K. All right, and that's graphing all those points. Okay, that's all we have for the imaginary unit I. If you have any further questions on this, please feel free to ask. Thanks.